Hi guys. Imagine you and your friends are trying to find the fastest route to a restaurant in a new city. One friend only knows what the others tell him. He follows them blindly. Another friend opens Google Maps, sees the entire city map, traffic, and picks the best path himself. In computer networks, routers behave the same way. Some routers forward packets based on only what neighbors tell them. So it is distance vector routing. Some routers sees the entire network and take their own decision and it is link state routing. So which friend do you think makes the safest and fastest decision? Okay. Today we will see how routers make decisions exactly like those two friends. By the end of this presentation, you will understand how distant vectors work, how link state works, why they behave differently, which one is better in which situation, and I will explain everything with simple real life example, no complicated theory. Hey guys, this is Varun KG and our teammates are Varun Kaushik BR and Rishikesh. Come on, let's try to understand what is two approaches to network routing. Routers are the backbone of the network communication, responsible for determining the most efficient path for data packets to travel from source to destination. Two primary methods have emerged as industry standards: distance vector routing and link state routing. Each approach tackles the routing challenges differently with distinct advantages and traits of that makes them suitable for various network scenarios. Distance vector routing, the neighbor's perspective. Neighbors neighbor only update routers chase distance and count information executively with directly connected neighbors, creating a limited view of the network. Trust based decisions. Routing tables are built based on the information received from neighbors without independent verification of the entire network topology. Slower convergence. Network changes propagate gradually from the router to router, increasing the risk of routing loop and inconsistent information during updates. Billman Ford algorithm uses of straightforward mathematical approach that calculate the shortest path based on distance matrix provided by the neighboring routers. Link state routing, the complete map. First one, full network topology. Every router maintains a complete map of the entire network, enabling informed and accurate routing decisions. Rapid convergence. Changes are broadcast immediately to all routers, ensuring fast updates and eliminating routing loops through synchronized information. Descartes' algorithm employs a sophisticated shortest path algorithm that calculates the optimal route based on complete network knowledge. And last one, higher resource use requires more memory and processing power to maintain detailed topology databases and perform complex calculations. So let's see the key difference at the glance. Network view. In distance vector limited to neighbor information only, but in link state complete network topology map. Update sharing. In distance vector exchanges routing tables with direct neighbors, but in link state broadcast link state information to all routers. Convergence speed. In distance vector slower gradual propagation, but in link state faster immediate network wide updates. Routing loops. In distance vector possible during convergence period, but in link state loops free by design. And algorithms used Bellman Ford, but in link state it is discreta. Okay. Resource used resource uses lower memory and processing requirements, but in linked state it is higher memory and CPU demands. Let's see the complexity. In distance vector, simpler to implement and configure. In linked state, it is more complex but more reliable. And the last one, best use case. In distance vector, smaller network, simpler topologies, but in linked state, it is larger enterprises level network. And bottom line, but not the least, distance vector is straightforward and efficient to smaller networks. List link state offers superior performance and stability for complex large scale environment. Finally, in the last, the conclusion is in distance vector routing, each router only shares information with its neighbors and does not know the full network, which makes it simple but slower and less reliable. In link state routing, each and every router learns the complete network maps and calculate the best route on its own, making it faster, more accurate, and more stable for larger networks. Let us understand this simple topic by the simulation, which is explained by my teammate Varun Kaushik.
Hello guys, now let us start the simulation part of this distance vector routing and link state routing. First we will discuss about link state routing. In link state routing we are taking two different PCs and two switches, three routers, and in PC the PC is linked to configuration is IP configuration in that 192.168.1.11 as you can see here, and same it is directly connected to router through switch. In router also you can see in fast Ethernet same it is connected 192.168.1.1.1 and the subnet mask, and it is on. Now same this whole is connected as network A 192.168.1.0. Now this router has two different connections. One is for router 2 and another one is for router 3. Router 2 is connected serially with serial 2.2 as you can see here, and its address is 20.0.0.1, and the another router it is connected with same but the serial order is 20.0.0.2, and this is again another router is connected to this third router. In third router the serial 2 is 20.0.0.2 and 3 is 30.0.0.2. In the second router the serial 2.0 is 10.0.0.1. In serial 3.0 30.0.0.1, and as you can see here all are on and connected, and this is connected to the PC2. The PC2 configuration as you can see it is 155.165.1.1. So now let us start the demonstration. I am taking a message here. I will send it from PC 0 to PC 1. Now I will go to simulation part. Now let us start the simulation. See that the simulation it is going from PC to switch, and from PC switch to router 1. From router 1 it is going to router 3, which is the shortest path among the other routers path. In router 3 it is going to switch. From switch it is going to that PC2. From PC2 the message is received. Now it is receiving acknowledgement. The acknowledgement is coming back. From switch to router. From router 2 router 3 to router 1. From router 1 it is going back to switch, and from switch it will again come back to PC1. This is, as you can see, it is successful here, and you can see this here, it is successfully done. This is OSPF and link state routing protocol. So now we will start distance vector routing. In distance vector routing, we have taken example of RIP protocol suite. In this, we have taken 1, 2, 3, 4 PCs, 3 switches, and 3 routers. And this 2 PCs is connected to one switch, and PC3 is connected to second switch, PC4 is connected to third switch, and this is connected to router, which is, you can see here. First, the PC configuration is, I have mentioned in the note, but you can see inside also it is same. It is 192.168.10.2. Same, the PC2's address is configuration is 192.168.10.2. This is connected to switch, and this switch is directly connected to router. In router there are two paths. You can see one is for 10.0.0.1 and another one is 30.0.0.1 for router 1. And this router address, you can see fast Ethernet, it is 192.168.10.2, which is the address of the PCs of these two, which is directly linked to this switch. Now similarly, this router has the address of in config, you can see the fast Ethernet, it is 192.168.20.1, which is the address of the PC3 address, which is 192.168.20.1, and this whole address is switch. This whole is called network. And the another PC address, you can see here, it is 192.168.30.1, which is linked to router 3, and its configuration in fast Ethernet, you can see it 192.168.30.1, which is same as similarly like other routers. And this is connected serially to other 3 routers. First router is connected two ways. One, first router 1 to router 2, which is port number is 10.0.0.1, which is serially, and it is serial 2.0, as you can see here, 2/0, 10.0.0.1 for router 1, and for router 2 it is 10.0.0.2. Now this router 2 is connected to router 3 with 20.0.0.1 and 20.0.0.2. This router 1 and router 3 are connected with 30.0.0.1 and 30.0.0.2. And this is the basic structure of RIP protocol. And you can see in previous example we did connection through CLI command, but in this we did through RIP. As you can see here, we are connected here 10.0.0.0 and 30.0.00 for router 1 and its own address, router 1's address, and for router 2 we have connected in RIP, which is 10.0.0.0 and 20, which is the two paths of other two routers, and similarly for router 3. Now what is the difference? Now let us start the simulation. I am taking a message packet here. From PC1 I am sending the message to PC4. See, it is failed because the first it doesn't know the router. You can see that simulation also. From route PC it is going for switch. From switch it is going for router 1, and for router 1 it is going for router 3, which is the shortest path among all the these. From router 3 it is coming back to switch, and from switch it is for PC4. From PC4 it is coming back again to switch. From switch it is going back to router. From router it is coming back to router 1, and again it will come back to switch and switch to PC 1. As you can see, now it is showing successful. First it was showing unsuccessful because it was not knowing this router address before. Now it got to know the neighboring addresses. So first time it was failed, now it got successful. Thank you.